All right, good afternoon, grade sevens. I hope that you guys are all doing well and that your Wednesday has been productive so far, guys. It's time for us to get going with what is, I believe, the 12th lesson of the year, right? So we've made some very good progress so far, done lots of different topics, but we still have quite a long way to go. We've still got quite a lot of the year left ahead of us. But we are already in April, which is quite crazy to think about. So, guys, we are going to get started with some new work today, but I just want to give everybody a chance to quickly hop onto the live stream with us. So, while we wait for them to join us, I'd like to ask the same three things that I ask of you every week. Number one, if you're comfortable with doing so, please go ahead and type your names onto the comment box, into the comment box for me. Number two, make sure that you guys have got your stationery, please, right? You need to have your calculators with you now on a regular basis. I shouldn't have to necessarily remind you guys to bring it. This should just be common practice at this point, okay? And lastly, guys, please make sure that if you have any questions, you ask me. I'm keeping my eye on all of the comment boxes. Today is slightly different in comparison to normal because we are not only just live on Facebook, but now also on YouTube. Okay. So I'm watching and keeping my eye on both of those chats. The same applies for everybody watching, no matter where you are watching from. Please just make sure that you type your questions or your names into the comment box for me. All right. Okay, guys, we're going to get started in 1 or 2 minutes. I just want to give everyone an opportunity to join us, like I said, and then we are going to get started with today's work. Okay, if you have any questions for me in the meanwhile, you're more than welcome to go ahead and ask me about anything that's on your mind. But we're going to get started with some new work today. For the last 3 weeks, we've been focused on the world of exponents, grade sevens. Okay, we've gone through quite a lot of work so far, like I've said, and we've chatted from about everything from our integers and factors and multiples through to fractions. And now we've also spoken about everything we can think of regarding exponents, and that's taken us 3 weeks. So today we want to pivot onto a new topic, and we're going to move on to the world of measurement. Okay. There are a lot of different topics that we could attack, guys, but this is one of those topics that we do in term 1 and then again in term 3. So we want to talk about perimeter, area, volume, and surface area. We're obviously not going to get the chance to get through all of that today, but we will do our best to get as far as we can. All right. So let's get started, guys. I'm going to start by sharing my screen with you, just like I usually would. If you guys, for whatever reason, cannot see what I am writing or hear what I am saying, you guys are more than welcome to let me know, and I'll try and fix it as soon as possible. Somebody's asked why this is not on Facebook. Guys, we are live on Facebook and on YouTube in both places, okay? It's not that it's only one or the other. We're going to be trying to go live on both platforms as consistently as possible. It's something new that we are trying for today. Sorry, guys, my board has changed here for some reason. Okay, so let's get going with today's work. Like I said, we're going to be talking about the world of measurement. You should be able to see me scribbling on my screen in white, yellow, orange, and even green. If that changes and you cannot see what I'm writing or hear what I'm saying, please just let me know. Okay. You can write down today's date, which is the 9th of April, and today we are discussing the world of measurement. Now, measurement is a section of work that gets taken very seriously in high school. And seeing as you guys are in grade 8 now, you will see that next year there's a lot more focus placed on it than we would usually have in primary school. So you can write down today's heading and let's just quickly discuss what measurement means, okay? And then we'll get to writing down some notes. So measurement is the section of work related to understanding how we can literally measure different shapes for different reasons, right? We could be measuring the area of a shape, the surface area of a shape, which are two different things. We could be measuring perimeter or volume, right? And there are a lot of different kinds of measurements that we can do. And we have to understand what each kind of measurement is for, and then also understand all of the associated formulas that we're going to use. So for now, just as an example, you guys should know that the area of a triangle is half times base times perpendicular height, right? But as we move into high school, I'm not saying that you need to know this yet, but a volume of a sphere is 4 over 3 pi r cubed. Now that's completely different, and you guys might have no idea what that means, and that's okay. But what I'm trying to tell you is that we're going to run into so many different formulas that we need to understand what each formula is for and why we would want to complete each kind of measurement. Okay, so let's start with writing down some notes very quickly, and then we'll get into some of the formulas. We're not going to be able to cover everything today, guys. It is going to be a two-part lesson, so please just keep that in mind. But let's start at the very beginning. There are four main types or main kinds of measurement. Okay, we're going to write down some information about each of them, which is worth you guys writing down as well. I would recommend you guys take notes. It doesn't have to look exactly like mine does, but just write down what you think is worth remembering. Okay, they are your notes after all. So the first kind of measurement that we need to understand is the very simple concept of perimeter. Okay, the second kind of measurement is area. The third kind is surface area. And the fourth type is volume. Okay, so these are the four kinds of measurements that we need to understand, and you should keep in mind that each of these has their own unique symbol. Perimeter is perimeter is P, area is A, surface area is SA, and volume is capital V. All right, so we're going to dive into each of these and break them down just a little bit so that we have an understanding of each of them, and then we will move on to some examples. Okay, obviously, guys, I'm not going to sit here and test your understanding of perimeter for 3 hours. That's something you guys should already have a basic understanding of, but I am just going to go through it so that we have an overview of everything. Okay, so starting with perimeter, what do we need to know about perimeter? Well, we'll start with a definition. It is the length of the outline of a 2D shape. Okay, and it is important to write down 2D shape because some of these measurements exist only for 2D shapes and some work only for 3D shapes. Okay? Right, so perimeter is the length of the outline of a 2D shape. It has a symbol of capital P. That's no surprise. We already wrote that down earlier. What else do we need to know? It is measured in standard units. Okay. What do we mean by standard units? Grade sevens, excuse me. Standard units refers to normal millimeters, normal centimeters, meters, or kilometers. Okay, those are what we call standard units. It is different for area and surface area and for volume as well. Okay, so just keep that in mind. What else do we need to know about perimeter? Perimeter doesn't usually have many formulas, guys. So if we're looking at a square, for example, side, 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 right? A square has four equal sides. We could say that the perimeter of this square is 4 times s, right? 4 times the length of a side. Now, you guys can choose to memorize this if you want, but I always tell my students just pick a corner and mark it, and then walk around the shape and add up all of the sides. So s plus s plus s plus s will still get you to an answer of 4s, right? This is just a slightly different way to think about it, but there aren't necessarily very official formulas for perimeter. All right. You can copy that down if you'd like to, but it's not extremely important. So, what else do we need to know then about these measurements? Well, that's fine for perimeter. Like I said, you guys should have a basic understanding. So let's move on to area next. Number 2, the world of simple or plain area is the amount of space taken up by a 2D shape. Okay, by a 2D shape. Why is this unique? We're going to discuss why area and perimeter only working with 2D shapes makes sense, right? Remember, 2D stands for 2 dimensions, and we'll chat about that just now. Area, it has a symbol of capital A, right? Now, you can also write in brackets that it sometimes has subscripts. Okay? What do I mean by subscripts, grade sixes? Sometimes we'll write the area of a square or the area of a rectangle, or we'll talk about the total area, right? Or we can discuss the area of shape 1, or it's just area of shape 1 written like so. All of these little notes that we find at the bottom of the symbol A are what we refer to as subscripts. So you are allowed to use these, and sometimes because we need to calculate the area of multiple shapes in a question, it helps to have these subscripts, but you have to choose them logically, okay? You have to choose them carefully. Right, someone has said that they can't see me. I think that might just be an internet issue, okay? Everything looks okay on my side. So just double check your internet. Maybe you need to just close Facebook and reopen it again, okay? Unless the issue fixes itself. Right, so we know about subscripts now, guys. What else do we need to know? The last thing I want you to make sure you write down about area is that it's measured in squared units. Okay, you can either say square or squared units. That's why the D is in brackets there. Okay, what are squared units? Well, now we're discussing things like millimeters squared, centimeters squared, meters squared, or kilometers squared. Okay, those are squared units. You may not write an area answer without having squared units. You will lose marks or parts of a mark at the very least. Okay. Then, guys, you must know the formulas of three specific shapes for area. Okay, I'll write them down very quickly. For the area of a square, you know that we use length times width. The same is true of the area of a rectangle. It is length times width. And finally, the third one that you guys learned about more recently, the area of a triangle is equal to a half times base times perpendicular height. Okay, the reason why we place a lot of emphasis on understanding these three formulae is because when we look at, some other more complicated shapes, 90% of the time they can be broken down into a combination of these shapes. Right. Someone still says that the everything is a little bit blurry on their side. Grades sevens, if you don't mind, please just quickly tell me if everything is okay. If you can see everything properly and also hear me, please just type the word happy into the comment box for me, just so that I know if this is affecting more than just one person. If you can see and hear me all right, please type the word happy into the comment box for me. Okay. Guys, I suspect that there might be one or two people that are struggling a little bit with internet. I hope that this isn't affecting too many people, but you might just have to give it a little bit of time to fix itself. Okay. If not, remember there will be recordings available, but I'll remind you about that at the end of today's lesson. So this is pretty much everything we now need to know about area, guys. Okay, I hope that we don't have any questions just yet. If there is something you'd like to know, please type the questions you have into the comment box for me. It doesn't matter whether you are watching on Facebook or on YouTube. I'm watching both of the comment boxes, so just send me your questions as soon as you think of them, okay? With that being said, the third topic we need to discuss is going to be surface area. Okay, surface area is slightly different than the rest. So let's talk about surface area very quickly. What is surface area? This is the amount of space taken up by all of the faces of a three-dimensional shape. Right. So if I look at a cereal box, guys, and I'm trying to calculate the surface area of a cereal box, right? It's a 3D rectangle basically. I need to count the top, the bottom, the front, the back, the left, and the right, right? There are 6 sides on a cereal box. And when I'm calculating the surface area, I'm going to calculate the area of each side of the shape individually and then add all 6 of them in that case together. All right. It's the amount of space taken, oh, sorry, I missed the word up, taken up by all of the faces of a 3D shape. What do we need to know about its symbol? It has a symbol of capital SA. Okay, chances are if you see SA in a maths test, we are talking about surface area, not South Africa. Okay. And lastly, for surface area, is also measured in squared units or in square units, right? What are those square units? Millimeters squared, centimeters squared, meters squared, or kilometers squared. Okay. Right. Now, like I said to you guys, if we think about a cereal box as an example very quickly, when we look at a cereal box and we want to calculate its surface area, what we have to realize is that all of the faces, all of the sides of a cereal box are usually rectangles, right? Maybe some squares, depending on the cereal box. But what that means is that we're just looking for the area of rectangles and squares, and then we add it all together, right? So if we want to think about different formulas like we do for normal area, because there's so many different 3D shapes, we only have formulas for certain shapes. Okay, we're not going to write all of those down now, but you can write down under surface area that there are formulas for certain shapes. And a lot of these formulas, if you haven't learned about them yet, you're going to learn about them next year. Okay, that is definitely some grade 8 work, but it's helpful to know for now that there are in fact formulas. Okay, we just don't need to learn about all of them right now. So that is the world of surface area, which leaves us with one more kind of measurement, guys. Volume. Okay, volume. Now this is what really feels like the first taste of high school level measurement. In high school, you were going to be practicing surface area and volume calculations quite a lot, okay? So let's talk about volume very quickly. What in the world is volume? Well, we know that area, just plain simple area, is the amount of space inside of a 2D shape. Now, volume has to do with how much space we have inside of a 3D shape, right? And so one of the ways that a teacher used to explain this to me was they would say, imagine I have a tall cylinder, right? Like a Pringles can. If I decide to pour water into this Pringles can, how much water can I fit inside of it? Okay? That is what we want to think of when we think of volume. Filling a shape up with a liquid maybe, right? How much can I fit inside of this 3D shape? Now, remember, 3D means that we have three dimensions, right? It's a three-dimensional shape. So if, for example, I just think about a cube, right? This is just going to be a rough drawing. Please don't copy this one yet. If I draw a cube like this, what's unique about 3D shapes, grade sixes or sevens, sorry, I just taught the grade sixes, sorry guys. Grade sevens is that we have three different dimensions. We have length, the width, and the height of a shape, right? Now, if I multiply three dimensions together, what begins to happen? Well, let's say I had a centimeter times a centimeter times another centimeter. What does this do? This means that I now have centimeters cubed. And we've spoken about exponents. And so now you guys can see how the exponent of 3 is also read as being a cubic value. Okay, so centimeters cubed. And this gives you a hint as to what kind of measurement, what kind of units we use when we are discussing volume. So let's quickly write down some notes about volume, guys, starting at the very beginning. What is volume? Is the amount of space inside of a 3D, the amount of space inside of a 3D shape. Okay, now we will also spend time at some point in the next few lessons discussing the names of different three-dimensional shapes, guys. Okay, but it's important to remember that volume only works for 3D shapes. You cannot be asked for the volume of a 2D shape, right? Because it only has two dimensions. I can't fill up a square with water. I'm just going to pour it onto the square. But I can use a cube, right? So volume only works for 3D shapes. Volume has a symbol of capital V, which is recognized pretty much everywhere. And most importantly, guys, the last thing we need to know is that volume is measured in cubic units. Cubic is spelled C-U-B-I-C. Cubic units. Remember, we are still measuring some form of distance or length. So, in this case, we would be looking at millimeters cubed, centimeters cubed, meters cubed, or finally, kilometers cubed. And please remember that if I write, for example, centimeters cubed, the 3 is an exponent. You do not write it next to your centimeters. It must be written to the top right as a smaller number. Okay, it is a power. We've discussed that enough now for you guys to have a rough idea of what that means. Okay. So the last thing I want to mention about volume very quickly before we dive into our first example of area and perimeter is that if I have got 3 dimensions on a 3-dimensional shape, what does that mean when I'm calculating the volume of a shape? Okay, just like area and perimeter, or area, just plain area, there are going to be different formulas for different shapes. Okay, but the most basic is going to be for squares or rectangles. It's the length times the width times the height of that shape. Okay. Just like we would say length times width for squares and rectangles, because we have 3 dimensions, we now go and add on a third value that we multiply by. Okay, we're not going to dive into all of that too much now, but what you can do is quickly write a last point at the bottom here, saying that specific shapes will get or will have their own formula. Will have their own formulas. Okay, and again, guys, this is something you guys are going to practice an awful lot next year in grade 8. So you will learn about these different formulas for volume next year. Okay, but you do need to understand what surface area and what volume is for now at the very minimum. Okay, we are going to chat about this next week. We're going to dive into surface area and volume, but today, like I said, we can't do everything. So now that we've discussed the 4 main kinds of measurements that we have to deal with when we look at 2D and 3D shapes, we're going to quickly take a look at some examples of area and perimeter so that we can quickly remind ourselves of some of the basics that we have to keep in mind when trying these questions. So we've already written down quite a lot of information, guys, and I hope that you found some of it helpful, even if it is just a little bit like an overview to you. Let's go ahead and dive into a slightly harder example of perimeter and area. Okay. You guys are grade 7 now, so we're going to try a harder example. I'm not going to start with all of the basics. Right, calculate the perimeter and area of the shapes below. That's going to be our question. If you guys need me to move back up so that you can finish copying, or if you have any other questions, please let me know. I'll try and answer it as I go. So, do we have any questions, grade 7s? I apologize if I've called you guys grade 6s a few times. Sorry, guys. I don't do it intentionally. Is there anything you guys would like to ask me about? Okay. I haven't seen any questions just yet, so we're going to dive into the very first example of area and perimeter. I'm going to quickly draw up a shape for you guys, and we're going to talk through how we identify or calculate the area and the perimeter of these shapes. Okay, so I'm not going to give you guys very simple shapes, right? You guys already know how to calculate the area and the perimeter of a simple square or a simple rectangle. So that's not what I'm focused on right now, guys. Instead, what I want us to take a look at is the world of compound shapes, okay? Which means that we're looking at shapes that have been made up of multiple smaller regular shapes, okay? We're going to take a look at this shape over here. Right. I'm going to add some measurements. I'll give you guys a second to copy the shape down as well, and then we will move forward. Someone has asked if I taught grade 8. Um, I don't know if you're asking if I still do teach them or not, but yes, I taught the grade 8 students on Monday evening, and I will teach them again next week, Monday. All right. So let's take a look at this over here. We are told that this is a square over here, that these are both squares. We have measurements of 3 centimeters given on either side. This is obviously also 3 centimeters, and this is 7 centimeters. Finally, this is 5 centimeters, or 4. Let's rather do 4, sorry. Right, if this is a question given to you in a test or an exam grade 7s, you need to be able to do a few different things. The first thing you need to be able to do when approaching questions about area and perimeter is to understand what information you have been given first. So I've been given a few different measurements over here. We can see that everything is being measured in centimeters. And so what I would recommend you guys always try and start with is taking a different colored pen or pencil, preferably a pencil, and trying to complete the missing numbers on your shape. So because I can see this is a square, that's going to be a 3. So is this little length over here. This side is going to be 7 centimeters, because if this is a rectangle over here, grade 7s, if the bottom of the rectangle is 10 centimeters long, the top of the rectangle also has to be 10 centimeters long. The same is true for the other sides. If it is 4 centimeters tall on the left, it must be 4 centimeters tall on the right. So you must be aware of your shape's properties and characteristics. Okay, because now I can also put my last 3 over here, and now I have the length of every single inch of my shape. Right, there's no missing numbers, but there was a little bit of work I had to do to find it. We were asked to calculate the perimeter and the area, so we'll start with perimeter. You guys know that this isn't super hard. The perimeter of the shape is the length of the outline. Pick a corner. Grade 7s, I like picking the top left because I'm left-handed. So we're going to make our way around the shape. I start by moving across the top. That's 3. And down the right is another 3 and 4. So I'm going to say 3 plus 3 plus 4. I move across this part of the rectangle over here, which is 7. And down to the bottom of the shape, which is another 3. So I'm going to write plus 7 plus 3. Right? Moving across the bottom and back up the left, there's 3 centimeters, 3 centimeters, and another 4. So plus 3 plus 3 plus 4. Then I move across the top of the rectangle again, which is another 7 centimeters, and up the left of the square, which is another 7 and another 3 centimeters. Okay, now what's helpful to do, grade 7s, is to count the number of sides on your shape that should be included in your perimeter. So if I take my highlighter, I can highlight across the top, right down the right-hand side. That's 1, 2, 3 sides, 4, 5, 6 measurements I need to include. This would be 7. Oh, sorry, that's 6. There's 7, 8, 9, and 10. I have 10 individual measurements that I need to include on this or in this perimeter calculation. So if I go and count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? We counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides on the shape. So you know that you haven't missed anything. You can then throw this into your calculator. 3 plus 3 plus 4 gives us 10, 17, 20, 23, 26, 30, 37, 40. So the perimeter of this shape is the value 40, but we measure perimeter in standard units, so it's just plain old centimeters. Okay. Now, remember, I'm going to quickly take out my red highlighter. You do not include these two lines running through the center of the shape. Okay, that is not included in the perimeter because it does not form part of the outline. So with that being said, you guys know how to do that. So let's take this up a notch, right? We're going to make this slightly more complicated. I want to quickly just erase all of these numbers over here. So just excuse that for a second. I'll rewrite them properly now. Okay, so we know we have 3 centimeters on all 4 sides of the square, 4, 7, another 3 over here, 4 on this side, and 7 over here. So there is our shape back in its beginning state. If we need to calculate the total area of this shape, grade 7s, remember, we do not have a formula for the area of a shape like this, but it can be broken down into some smaller shapes. We have 2 squares over here and over here, right, that are exactly the same size. And we also have a rectangle in the center, which we're going to need to work with. So we need to calculate the area of these squares and the rectangle and then add everything together. So what we can do is start by saying that the area is equal to A. But we also know that the total area for this entire shape is equal to the area of a square plus the area of another square plus the area of a rectangle, right? Now you can see those subscripts that I was talking about earlier. The letter T means the total area for the whole shape is a square plus a rectangle. Okay, if you guys would like to use color for this and match the diagram colors with your calculation colors, that's completely fine. But how do we do this? Let's start at the very beginning. I'm going to leave a little bit of space and say that we need to start with the area of a square. How do we find the area of a square, grade 7s? We know that the area of a square is simply length times width, but you must include this step. You must write down the formula that you're using. The length of this square is 3 centimeters and the width is also 3 centimeters, right? We can see that on our diagram over here. And both of our squares are identical. So we don't have to do 2 separate calculations. 3 times 3 gives us 9, and centimeter times centimeter gives us centimeters squared. So the area of our squares are 9 centimeters squared each. But we also have a rectangle to deal with, right? What is the area of a rectangle going to be? It is also the length times the width. Looking at our rectangle over here, the length is going to be 10 centimeters. Why not just 7? because it also extends past to above the square. So 7 plus 3 gives us 10 centimeters for the full length of our rectangle, while it's 4 units wide. So we're going to have 10 centimeters multiplied by 4 centimeters. And when we multiply the numbers together, 10 times 4 gives us 40. And centimeter times centimeter gives us centimeter squared. Now, it does depend on how your teachers are going to mark things, grade 7s, but you could probably get a total of 3 marks for this calculation and 3 marks for this calculation. Maybe only 2 though. Okay, let's assume for the sake of this example, you get 2 marks for this, 2 marks for this. You will also get 1 mark for saying that the total area is the area of 2 squares plus the area of a rectangle, right? Please remember these 2 squares have the same dimensions. They are both 3 centimeters wide by 3 centimeters long. So if I want the total area of this shape, because I have these calculations at the bottom, what am I allowed to say? The total area of this shape, grade 7s, is going to be 9 centimeters squared for the first square, plus another 9 square centimeters for the second square because they are the same, plus the area of the rectangle is 40 square centimeters. And so when I add all of this together, guys, the total area of the shape that we've discussed today is going to be 58 square centimeters. Okay. And there we go, guys. That's how we practice calculating the area of a compound shape. I'm going to quickly move these calculations over to the side over here so that you guys can see everything in one picture. Okay, you don't have to lay your work out exactly the same way I do, but you do need to lay it out in a logical format because it doesn't matter who's marking your work. If they cannot understand how you are getting from one step to the next, they will take off marks. All right. And again, pay close attention to how I've underlined my 2 final answers, right? I've also done it for these 2 sub answers, and that helps because it shows your teacher how you've progressed through your question, which is more important than you might think. Okay, guys, we've got about 10 minutes left of today's lesson. I know that we've been doing a lot of talking, but just very quickly, it's going to take time for us to practice perimeter and area. I think you guys have a pretty good understanding of how perimeter works, right? That's nothing fancy, but as far as area is concerned, we do need to be able to practice some more niche shapes, right? Squares and rectangles aren't so bad, but keep in mind they can be combined into compound shapes like this, which you might have to work with. If you ever see a compound shape, break it up into its pieces. I want to move on, but I'm going to give you guys 1 more minute to quickly finish copying. If you guys have any questions, it doesn't matter if you're watching on Facebook or on YouTube, grade 7s, please ask me now. Okay. It doesn't have to be about this exact example, but you do need to ask me if there's something on your mind. Okay. Now, when we talk about area grade sevens, we know that squares and rectangles are easy. So what else do we need to know? And unfortunately, I'm obviously not going to be able to get through everything today, guys. This is already quite a lot of work. But what I wanted to show you with this one example is that number one, we need to break up compound shapes, right? Even in high school, we do this. I know this might feel like a simple example, but it's teaching you things in the background you might not notice. You need to learn to lay your work out in multiple steps so that it's easy to understand, right? We start with talking about our symbols and our formulas always. Then we substitute, right? We put the numbers into our formula and then we give our final answer and we make sure that we show all of our working out, right? That's really important. So I wanted you guys to see here how we really lay things out, how we apply all of the different formulas that we have, how we have to be very aware of the units that we attach to our answers, right? Perimeter and area don't have the same units. We have to practice this a lot because when we also now add on surface area and volume, we've got to be able to distinguish between all of them. That's why I started by giving us an overview of everything in the beginning. Okay. I've got one question that's asked, do you have more lessons for other subjects? Guys, unfortunately, no, we don't at the moment. Okay. I am uh, focused on teaching you guys maths at the moment. This is my, my specialty, if we can call it that, right? I love teaching maths. I've spent so many hours teaching it. And that's what we're focused on for now, because that's what a lot of people struggle with. If you guys want us to offer tutoring like this once a week for other subjects, let's say maybe English or science or something like that, just do me a favor, please, and type a message into the comment box now. It doesn't matter if you're on Facebook or on YouTube. Just say, can we please have lessons for this subject? Okay. Because what that does, guys, is it allows me then to talk to everyone else that I work with, and we can slowly try and make more plans for you guys to help you as much as possible. Okay. But if you don't ask for it, we're not going to give it to you. All right, because we only want to give you what really helps. I hope that answers your question. Then someone else has asked about square roots and cube roots. I'll answer that question in just a second. But guys, I hope you've had an opportunity to copy now. What I want to do is quickly show you iRainbow like I do most lessons. So just bear with me. I'm going to stop sharing the screen you can currently see. If you need me to come back to it, let me know. But for now, I want to show you a different screen. Okay. So I'm going to give it a second to quickly reflect on your side, but you guys should be able to see iRainbow popping up. Okay, this is my iRainbow, but yours should look pretty much the same. You guys can see how many different topics there are that we can practice and make our way through this year. So I really hope that you guys do use this as a resource. Today we are focused on measurement, right? That was today's lesson heading. So we're going to click on measurements and go across to, over here to geometric shapes. Measure geometric shapes. And over here, you can see that we have quizzes on the 4 different forms of measurement that we discussed in today's lesson. There are quizzes on perimeter, area and perimeter of rectangles specifically. Then we talk about things that get a little bit more tricky, which are triangles and trapeziums. Now that I would like to talk about in next week's lesson, amongst 1 or 2 other things. But It also talks about more word, area and perimeter questions, but in word problems, right? That's also great to practice because sometimes interpreting questions can throw you off. And then finally, there's also quizzes here for volume and surface area, as well as a quiz where we just throw everything into one. So guys, I hope that you can see that this is going to be a huge help to you guys while you are studying. But for example, just for the sake of me showing you guys how this works, let's click on triangles and trapeziums over here, the second quiz in the right-hand column. If I click on this, there's 3 levels. For those of you that don't know, level 1 is very easy, level 2 is a little bit harder, and the third assessment is the timed assessment. The reason we have that is because it gives a student an opportunity to practice under time pressure like you would have in a test, because it helps you to feel more confident under pressure then, right? And you don't feel really anxious and then get worked up before a test and even start forgetting things, right? So it's really worth your while. Let's click on level 1. It says find the area of this triangle, right? Now, I'm not going to go through all of this with you, but for example, I want you guys as grade 7s to please understand that you need to practice writing things down. I have a triangle over here with a height of 8 centimeters and a base of 6 centimeters. So if I quickly draw just a very rough sketch of this, we said a height of 8, right? We have 8 centimeters here, 6 centimeters here, and it doesn't really matter what's over there. Whenever we start a question regarding area, we start it the same way. Area is equal to A, and you guys should by now know that the area of a triangle is a half times base times perpendicular height. The half is going to stay as is. Our base is the 6 centimeters over here, so we can fill that in. And we also need the height of the triangle, which is going to be the 8 centimeters over here, right? When we multiply all of these together, you guys will see that the area is going to be 24 square centimeters for this triangle. Now, the reason I've quickly done that is because I want you to see how much you need to practice writing out. I know that some of you might be able to do this in your head, but I strongly recommend that you don't do that, because in a test setting, this is worth 3 marks, right? So if you do something in your head and you make a small mistake, you're going to get the wrong answer and then not get any marks at all. So I would recommend when you go through a quiz, write your work down like this, then take your answer and put it into the software and submit it, and it'll mark it for you. And as you make your way through a quiz, grade 7s, you're going to get a pretty good understanding of how much you know, right? I'm not going to go through all of this with you, but for example, here we have the area of a trapezium, okay? If you guys feel confident enough to try this, you can go ahead and give it a shot. But I'm simply showing you that you have this section on geometric shapes that gives you the opportunity to test yourself, on any of these different topics, okay? And that's really useful when it comes to preparing for tests and exams. So guys, go ahead and use iRainbow. You now know where to find the quizzes for today. So if you want to quickly go and brush up on your perimeter and area for rectangles and squares, go ahead and try that. Then we'll tackle some new work again next week. But I hope that today has given you a little bit of an overview as to what the world of measurement is really all about. Okay. But guys, that's going to be it for today. I know that was quite a busy lesson. If you have questions, now's a good time to quickly type them into the comment box for me. I'm going to stop streaming just for now. I know that somebody asked about square roots and cube roots. I'll quickly discuss that in 2 minutes. But okay, I see you guys um, asking a few questions. Sorry, I wasn't able to see the chat for a minute or two. Let's answer questions very quickly. First things first, is it possible to find the area without separating the compound shape? That's a little bit tricky. It's not impossible, but there is no formula for example, the shape that we discussed, right? There is no formula to find the area of that shape. So is it possible? It might be, but there's no point in trying to find any other way to do it, right? When we run into all kinds of weird and wonderful shapes out in the world, we still need to follow this process of breaking it down into its smaller pieces, right? Into shapes that we recognize and know how to deal with. So I hope that that answers your question. I've never taught students to calculate it without separating, and I've never been taught that either. So you're more than welcome to give it a go, but I would recommend you just stick to separating the shape. Okay. Can we have EMS lessons? Thank you. Can we have English lessons? We will ask. Can we have Afrikaans lessons? I will also ask. Okay, guys, thank you for putting those messages into the comment box for me. That really helps. But guys, we're already 3 minutes over time today. I hope that today's given you a rough understanding of what the world of measurement looks like and maybe what you can look forward to moving into high school when it comes to the section of measurement, right? Looking at more tricky examples of surface area and volume and so on and so forth. We will be continuing with work similar to this again next week. Keep in mind that our next lesson is going to be next week, Wednesday, again from 5 o'clock to 6 o'clock in the evening, guys. I hope that you guys will join me for that so that we can continue making our way through the grade 7 syllabus and I can keep giving you guys as many tips and tricks as I have. But guys, that's all we're going to have for today. If you have any other questions, now's the time to quickly ask. I'll try and answer them before I am done for the day. But guys, thank you so much for attending, asking questions, and sharing your requests with me for other lessons. I will make sure to point it out and discuss it with the other people that I work with, and hopefully we can make a plan for you guys. All right. But grade 7s, that's going to be it for today, guys. I hope you have a fantastic Thursday and Friday ahead. And I'll speak to you guys all again next week, Wednesday from 5 o'clock to 6 o'clock in the evening. All right. Thank you so much, guys. Please just remember, there are lesson recordings that are available on Facebook still, but we've now decided to try and go live on YouTube at the same time. It is going to take a little bit of time for our video library to build up on YouTube. So for the meanwhile, if you guys want to go and watch lesson recordings of the lessons we had, for example, on exponents, square roots, cube roots, and so on and so forth, you can just go onto the iRainbow exclusive community Facebook page and scroll down and you'll see all of the different lessons for all of the different grades that we teach. Okay, that'll just give us an opportunity to build up the video library on YouTube, but hopefully having YouTube and Facebook is going to make it a little bit easier for you guys to access the lessons. All right, that's it for today, guys. Thank you so much for attending. You guys are more than welcome to go if you are happy. There was one student that quickly asked me about square roots and cube roots. I'll quickly give you an overview. I unfortunately cannot do an entire lesson now, obviously, on this topic alone. And I will suggest that you go back and watch the recording that we have on Facebook for the lessons that we did on exponents, okay? But you need to understand exponents before you can understand square roots and cube roots. So if I have 4 squared, for example, it means I have the number 4 multiplied by itself twice. And 4 times 4 is going to give me 16, right? Same thing would apply if I had 5 squared. Or let's say 5 cubed. right? 5 cubed, or 5 to the power of 3, means I have the number 5 multiplied by itself 3 times, which is going to give me 125. Now, if we think about the four major operations, um, addition, subtraction, multiplication, and division. If I add two numbers together, I can subtract to sort of undo the effect of adding, right? We call it an inverse. If I multiply something to make it bigger, I can undo that by dividing to make it smaller. Now, the same thing is true of squaring and square rooting and cubing and cube rooting. So if I take a value x in this case and I square it, the opposite of that would be to square root that value, right? And if I cube a value, like the 5 that we did, the cube root would be the inverse of that. So if we go to these two examples that we've done over here very quickly, right, let's just make these a little bit smaller. If I square a number, I get to 16. But if I ask for the square root of 16, I'm asking myself, what number can I times by itself to get 16? Right? So the square root of 16 is 4. And so we get from where we started back to or where we ended back to where we started. And the same thing is true of cubing. Right here we had 4 squared, and we decided to square root to get back to 4. If I have a number being cubed, that means that I can now do the quote-unquote inverse, right? What feels like the opposite. So now I can cube root 125, which means I need to ask myself, what number can I multiply by itself 3 times to get 125? And the answer to that is the value 5. Okay, so you can see if we're cubing, to undo it, we cube root, and we can get back to the answer, or sorry, we can get back to where we started from the answer using this sort of method. Okay, so I think a lot of people don't understand that squaring and square rooting, right, these two functions over here, you might just want to write down the names so that you understand what's what. This is the process of squaring when we have something that has an exponent of 2, and square rooting is using that root sign where there is an imaginary 2 sitting over here. We don't write it, okay? And the same is true for this. When we have some value to the power of 3, we refer to it as cubing. And the sort of inverse of that, right? The way we can undo that is by cube rooting. All right. Now, I unfortunately cannot spend too much more time discussing this, but I hope that this gives you a very brief sort of overview of what squaring, square rooting, cubing, and cube rooting really means. All right. Now, I would recommend that you go back and watch the video that we have on our Facebook page. You can go back to the 2nd of April, okay? On the iRainbow exclusive community Facebook group, you can go back to the 2nd of April, 2025, and go and watch the grade 7 recording from that day, and you'll see we had a lesson on exponents. Okay, and while you're there, take a scroll through the rest, see what else there is that you can learn at the same time. But guys, that unfortunately is going to have to be all for today. Again, thank you so much for attending. I really appreciate you guys coming to watch and see what these lessons are all about. Thank you to those of you that keep coming back. I know some of you quite well by now. But guys, that really is going to be it for today. I hope this little explanation I did on the screen sort of explains the world of squaring, square rooting, cubing, and cube rooting a little bit better. But like I said, go and watch that video for a little bit more of an in-depth explanation. Okay. Right, guys, that's going to be it. If you guys have any more questions that you think of, either now or during the next week, please make sure that you write it down on a piece of paper or remind yourself somehow that you want to ask me that question. And then when we meet for our next lesson next week, Wednesday at 5 o'clock, you can ask me whatever you had or whatever you thought about over the last week. Okay. Guys, have a fantastic evening and an even better Thursday and Friday ahead. And I will chat to you guys all again next week. Okay. Thank you for all of your suggestions. I will take them with me and make use of them. But that's all that we have time for today. All right. Thank you so much, guys. I'll chat to you all next week.